Okay, so reference angles. I started with the radians one, which is a little bit tougher, but we can handle it here. Reference angles are the angles you use to help you evaluate a trig function. So like, for instance, if you have theta equals, let's do 110 degrees, okay? You draw 110 by starting on the initial side. Here we go, we're at 0, now we're at 90 degrees, and 110 is a little bit more, so this is where 110 degrees is. The reference angle is the angle you make when you construct that triangle, okay? And we construct triangles by making a right angle with the x-axis. So here is the reference angle, okay? So for this problem I just put up here, if this is 110 degrees, then there's 70 more degrees for the reference angle that goes down here in the triangle. That's the angle you use to evaluate the 6 trig functions, sine, cosine, opposite, the hypotenuse, and all that stuff, okay? So in short, the reference angle, you draw the angle that you're given, and then you construct a triangle with the x-axis, okay? Make a right angle with the x-axis. The reference angle is that interior angle that's an angle that's made with the x-axis. Okay, so now that we know that, let's see what we can do here. We're supposed to find the reference angle for negative 16 pi over 9. Let's convert that to degrees first, okay? And there's several different ways of how to convert from radians to degrees. This isn't the shortest, but I think it's the one that makes the most sense. Multiply by 2 pi with a 360 up top. Because 360 degrees is the same thing as 2 pi. Because 2 pi is the circumference of a circle, 360 is the circumference of a circle. You're multiplying this radian measurement by 1, effectively. Okay, and I put radians on bottom instead of on top so that your units would cross cancel. Okay, so the pi's cross cancel. We can cross simplify. Negative 16 and 2, they're both divisible by 2, so this is negative 8, and that's 1. And then cross simplifying over here, 9 can divide into 360. That makes 40 degrees. 9 divided by 9 makes 1. Or you could have just multiplied straight across and simplify the fraction. Okay, but negative 8 times 40, negative 320 degrees. Okay, so let's draw negative 320 degrees. Here's your initial side, which I made too big. Okay, so if you start from your initial side, this is negative 90 degrees. Negative means you just go in the opposite direction. Negative 180, negative 270, negative 320 degrees lands us right here. Okay, now that we always draw a reference angle by starting with our terminal side and make a line that makes a right angle with the x-axis. So if you used up 320 degrees going this way, there's 40 degrees left to complete the circle. So our reference angle is 40 degrees. But they want the answer in radians, so we're going to take that 40 and we're going to multiply it by that conversion factor again. We need the units to cross simplify, so I'm going to put 2 pi up top and 360 on bottom. So that gives us 80 pi out of 360, which, well, that can simplify. Whoa, hard to do in my head. I often find my students are better at doing mental math than I am. Oh, that's yucky. 2 nights. Okay, I'm trying to think of an easier way to say it. One thing I do, if they're both divisible by 10, right? Because I got a trailing 0 here. So divide them both by 10. Now I see they're both even. Let's divide them both by 2. That's 4 pi over 18. And look, they're both even again. Let's divide the top and the bottom by 2 again. That's 2 pi over 9. Okay, if I did everything right, or else I don't know what I'd do. Okay, phew. So then other topics, this one just straight up gives you degrees, so this one's a little easier. You don't have to do all the radian conversions, okay? Negative 32, this is negative 90. This is roughly where negative 32 is. Make a right angle with the x-axis. Now, if you've gone 132 degrees that way, 180 subtracted by 132, that gives us 48 degrees left over for our reference angle.